This one is the hard.
Question 9 of week 2A homework. So in this question, we are given a living cell and we are trying to find out how much work the electric force does when a sodium ion, which I drew over here, moves inside of it. So first up, I made this sketch and we have the outside of the cell on the top and we have the inside on the bottom between the two parallel lines. And so the problem tells us that the outside has a higher potential than the inside by 0.087 volt because the positive charge naturally low potential moves to low potential. So this positive sodium ion is going to want to move inside on its own. And that means that the electric force is doing positive work to pull it in, sort of like gravity pulling a ball down onto a hill, like that. So first, let's identify our variables. So we have W, which is work. And actually, I'll just use the typing box. W is work. And it's the amount of energy transferred by a force. And its SI unit is in joules of energy by a force, joules. Next, we have Q, which is charge. And it's the amount of electric charge of the particle. Of the on the particle, and its SI unit is in coulombs. Next, we have E, which is elementary charge, and it's the fundamental electric charge of a single proton or electron, which is a constant equal to 1.60 times 10 to the negative 19th. And I'm just gonna write um what it's equal to because it will be too much work to write it all down. To the negative 19 coulombs. And then we have delta V, but I don't have a delta symbol, but delta V, and it's the electric potential difference over the voltage drop. Electric potential difference over the voltage drop. And the difference in it's the difference in electric potential between 2 points, and its SI unit is in volts. So before we start, let's list our values so we don't like lose track of everything. So our charge Q is equal to positive E because it's a single sodium ion. So the constant for E is just 1.60 times 10 to the negative 19th coulombs, like I wrote here. And our charge in potential or the voltage drop is delta V, which is 0.087 volts, as I wrote over here. So the main equation we need to connect work, charge, and voltage is W is equal to Q delta V. And so basically, it just means that work is just the charge multiplied by the potential difference it moves through. So if we just plug in our numbers into this formula, we would get W is equal to 1.60 times 10 to the negative 19 coulombs times our V, which is 0.087 volts, as I wrote here. Um, and so when you punch this entire equation into the calculator, um you would get approximately 1.392 times 10 to the negative 20. And if you round that to three significant figures, you would get just 1.39 times 10 to the negative 20. And the unit is in joules. And because that's a standard unit for work and energy. So yeah, that's the total work done. Oh shoot, joules. And so that's the total work done by the electric force to pull the sodium ion over here inside into the cell through the cell membrane. And thank you for watching.